Hello dear students, today we are going to talk about anthropological stability of geosystems. The following questions that we are going to discuss. First one, anthropogenic modifications of natural geosystems. And second question, geoecological factors in the development of technogenesis. Geoecology directly studies the results of manifestation of anthropogenic activities of society, including the spread of pollution in the environment. The most common factors in the development of technogenesis are climatic, aeolian, geomorphological, exogenous, as well as hydrological. The effect of climate factor is based on the global change in the reflectivity of the Earth's surface and the dynamics of gas composition of the atmosphere, mainly greenhouse gases causing climate collisions. In turn, climates determine the movement of air mass along with humidity and temperature, form the main ecological and geoecological features of atmospheric processes, like windwork, gale storms, tornadoes, cyclones, hurricanes, and others, thunderstorms, lightning, droughts, snowfalls, floods, mudfloods, landslides, and others. Climatic conditions have a great influence on the spread of technogenic flows. Therefore, it is very important for the successful development, use of natural resources, the functioning of the economic complex of territories, and preservation of human health to know the peculiarities of climate and their influence on the migration of chemical elements in the natural components of geographical envelope in specific territories. The factor determining the heat exchange of atmospheric air with the Earth's surface is the temperature difference between the air and Earth's surface, which arises due to the differences in the heat balance and, above all its component, the radiation balance. And an important mechanism for the spread of pollution is the degree of moisture content of territory. Excessive, wet, insufficiently wet, and dry. The degree of moisture is characterized by an index that varies from less than 0.45 to 3, and more than 3 is already the index of dryness of territory. So, zones with excessive moisture content of territory are characterized by the predominant dispersal of pollutants, neutralization of industrial and household waste. At the same time, it is known that processes of concentration of pollutants or products of their neutralization prevail in dry subzones. The ecological factor in the development of technogenesis is of a twofold nature. On the one hand, it is an exogenous process involving corrosion and deflation. On the other hand, wind erosion is considered as a climatic manifestation. With the existing difference in the approach to the process, its essence remains the same: formation of terrigenous aerosols in the atmosphere. The terrigenous basis of aerosols in the atmosphere is formed by dust storms, hurricanes, mudflows, droughts, landslides, and others. The listed exogenous agents should be considered in close connection with the climatic factor, as well as the lithogenic basis and the relief of the area from which the terrigenous material is transported in atmosphere. Next question is geomorphological factor, mudflows, landslides, and other exogenous factors. It is known that when air masses move over the Earth's surface, they carry aerosols, dust, and pollutants together with heat and moisture. In this case, the air masses gradually change their properties under the influence of the underlying Earth's surface. The converted air acquires the features of continental tropical with low humidity, but with high dustiness. In mountain conditions, air flows from the higher parts of the mountains, which brings and deposits fine dust particles from the watersheds in the lowlands. Usually under the influence of a ridged relief, motion slows down in the lowest layer of the troposphere, on the order of several tens, less often hundreds of meters, which leads to the formation of upward and downward turbulence currents, transport and deposition of aerosols and dust. The influence of geomorphological factor on the pollution of the Earth's surface is usually considered in the light of interaction of circulation, air masses, and the Earth's surface in certain natural situations. For example, let us consider two regions differing in geomorphological structure: highly plain, the central part of the Siberian plain, and mountainous, like Central Asia, Geyser Alai. The first is characterized by the effect of air flow around single heights, and the recorded increases in precipitation and pollution from the windward side are explained by the action of ascending air flows caused by the intense roughness of the Earth's surface. The physical aspect of the influence of geomorphological factor on environmental pollution within the central part of the Siberian plain is based on the size of ground object that perturbs air flows. So low elevations affect the atmospheric flow by the size of a single hill or a group of hills. In the case of a single hill with an insignificant base length, the amplitudes of fluctuations in atmospheric flows rapidly decay. In the presence of a large base or a group of hills, attenuation occurs more slowly and is indistinguishable from the general circulation of atmospheric air. Studying the influence of natural factors on the development of technogenesis, one should not forget about their role in the natural mass transfer of chemical elements between the components of nature at different barriers. So the manifestation of landslides and mud flows seemingly far from the general problem of technogenesis, but due to the fact that they appear in border environments like air, soil, river runoff and rocks, chemical elements in these environments are involved in migration flows, mud flows and landslides. They manifest themselves in close connection with the climatic factor. River flow destroy rocks, transfer soil material and chemical elements that have fallen out with atmospheric aerosols and from industrial enterprises. Mud flows are involved in the transportation of rocks mixed with water. They transport or redeposition mudstone material as well as chemical elements accumulated in river bottom sediments. Especially a lot of technogenic matter is transferred when mud flows capture dumps of mining and processing plants and tailings from metallurgical processing. Landslides, being by nature a manifestation of exogenous processes, act as a mechanism for the transfer of lithogenic material and technogenic pollution contained in soils and water flows. All landslides are confined to high and steep slopes. The driving force of a landslide process is the climatic situation, which contributes to the accumulation of moisture and the breakdown of masses of rocks along the slope. The primary cause of landslide formation is a combination of surface temperature, high humidity and steep terrain. The hydrological factor in the development of technogenesis is determined by the regime of river flow, climatic zoning of the drainage basin, water pollution with technogenic substances, and accumulation of pollution. Among the anthropogenic sources of human substances, the main ones are wastewaters from industries and utilities, as well as waste from industrial enterprises, waste from the development of ore and non-metallic minerals, waste water from mines, oil fields, discharge of water and rail transport. River water pollutants are oil, phenol, pesticides, complex organic compounds, synthetic detergents and heavy metals. The main areas of environmental protection from chemical products of industrial production today include the following. First one, improvement of technological processes, replacement of outdated technologies. Next, transition to low waste and resource-saving technologies. Then efficient treatment of industrial emissions and effluents of improvement of treatment equipment. Complex processing of slags with preliminary extraction of non-ferrous and rare metals. Capturing dust and gaseous harmful substances from waste gases. Capture by companies from wastewater. Introduction of recycled water supply. Rational location of enterprises, taking into account the topography of the area and the direction of the winds. Environmentally friendly waste disposal and organization of sanitary protection zones around industrial enterprises. Various methods are used to clean up gas emissions entering the atmosphere and neutralize aerosols. For example, adsorption, cleaning gases from gases and vaporous impurities based on their absorption by porous bodies, adsorbents. Thermal methods of direct combustion are also used to neutralize gases from easily oxidized toxic or foul-smelling impurities. Condensation methods, catalytic methods, and others. For wastewater treatment, use usually mechanical cleaning, psychochemical methods, electrochemical methods, and biological methods. There are several types of biological wastewater treatment devices, via filters, biological ponds, irrigation fields, and aeration tanks, like reservoirs with activated sludge of bacteria and microscopic animals. Environmental pollution with human waste, especially chemical and radioactive, already today has a very significant impact on the entire planetary situation. First of all, it has a noticeable effect on the health of population and the state of natural ecosystems. Waste disposal methods are largely determined by the specifics of the economy and characteristics of the waste itself. Let's name some of the requirements for the applied methods of processing industrial waste. First one, widespread implementation of various technologies for mechanical neutralization and processing of solid waste. It including mechanical sortation, crushing and subsequent heat treatment of waste, and incineration of many types of solid waste and organic matter in incineration plants, remelting, slag burning, and others. Second applied method, a significant increase in the scale of waste processing with the extraction of valuable raw materials. Third one, sorting, decontamination and storage of waste at special landfills and dumps, with the provision of environmentally friendly storage conditions. And waste disposal. Storage facilities should be impervious to groundwater. One of the promising ways is the creation of industrial complexes for waste processing within the regions. At the end of this video lecture, there are following questions for students. Thank you for your attention.